Hello, this is Professor Kim Nelson with the Jewelry Design Department at the Fashion Institute of Technology, continuing with our tutorial series for basic Rhino JD138. Continuing on with our project, the bridal ring. This is off. We want to round the edges of this object. And the easiest, in theory anyway, technology for that is going to be the fillet. So I'm going to turn off those curves, and I can actually throw away this red reference curve now with its points, because this is what I want. Now, before I go any further, I want to make a copy of this. Using grid snap, so I can be sure to get back if I want it. I'm going to put this on the storage objects layer. Turn that off, because I may need to come back to an unspoiled version of this. Okay, I want to know how big of a fillet I can do on this. To know that, I need to know how wide we are here. Curve from objects. First I'll see if I have an edge here I can grab. Nope. So, from objects, extract isocurve. Anywhere along here is fine. It's an approximation. Analyze the length of that curve. It's 1.9 millimeters. Okay. So knowing that, I should be able to get 0.9 fillet here. I'll back off a bit from that and try 0.58. I know it's going to fail, but I want to see how badly and where it's going to fail. Okay, it didn't disappoint. I'm going to turn off shank and actually look at the fillets themselves. See if there's much here to tell me what's going on. See, the fillets were fine coming into here and coming into here. It's this tight corner that they hated. It's where it all fell apart. Okay. Useful information. So, what we're going to do is we are going to make it so that it doesn't have to deal with that anymore. Extracting another isocurve. Going to come back from that tight corner a bit. We're going to do a surface, extrude curve, normal to surface. Normal means perpendicular from. We're going to select this outside as our base surface. Turn off grid snap. We're going to pull a surface straight down and click. And enter. I'm going to mirror this over to the other side. We're going to split this object, the shank. With these two planes. And then we're going to cap planar holes. And we're going to repeat the fillet command, see what we get. Fillet the other side too, just so we can see if we like it. Because we're going through a lot of work to preserve something. If we don't like it, there's no reason to do it. Okay. What we see here is that as it comes up into here, there's no way it can fillet from the underside here. And we want some filleting here. We don't need it as heavy as 0.85 at all. In fact, we wouldn't want that much, but we want a little bit of a fillet here. So let's undo those two fillets, Control Z, and see what we can fillet from this side. First off, let's see how much room we have. We can delete these. Remember, we can only fillet up to half the thickness of the item. So if it's 0.98, the most this could be filleted would be 0.48 roughly. And that's more than we need. Let's take a look at a 0.4. Oh, sorry. Put in 0.4 before you select this edge. Yeah, that's certainly sufficient. And let's see if it still holds its integrity. Okay, everything is getting along fine. So, I'm going to keep these two filleted surfaces here. Actually, I'm not, because what I haven't been checking with is the technology I'm using. Remember, the default for a fillet in Rhino is rolling ball, which means it does not stay consistent, and we need consistency because we still have to create the end of this, and we need the radius on the bottom and the top to be identical. If it's not identical, we have a real problem. Okay? So, first thing we're going to try, just to see if the Rhino gods are smiling on us, is to see... Oh, sorry. Got to extract surfaces. So solid. Extract surface. You know what's easier though, guys? Because that's going to create even more complicated surfacing. What's easier is to just go back before we split. Just undo back prior to the split. We're going to try and fillet the whole thing at 0.4. Just going to do the one side, because if it fails on one side, it'll fail on the other. See if it'll do a rolling ball. No. See if it'll do it distance from edge. And look here, you have rolling ball, distance from edge. No. Alright. It was worth a shot. Go ahead and resplit this. Get rid of those. Cap the planer hole. What I want you to feel as I'm working, guys, is that none of this is sacred to me. I can use things to sketch with. I can undo, redo. I can sacrifice things. I'm more concerned about a good strategy than I am about this piece. This piece doesn't mean anything to me unless it'll work. So, I know the 0.4 works on the inside. I'll go ahead and fillet that edge at 0.4, and I want both of these, and I want them to be distance from edge. Okay. For the outside, I want some more information from Rhino. I liked the 0.85 fillet. It can't come all the way up, but I'll bet it can come half the way up. So I want some reference geometry halfway up on these. I need some geometry I can snap to. And you'll see why in a minute. When I do a fillet command, it allows me to add additional handles that I can adjust to get a variable fillet, which is what I want to do here. But I need to have something I can snap onto to do that, and I really don't have that here. I'm going to make it so I do. I either have to drag a section curve, or I have to do a cut plane and an intersect. Remember, section curve is just a shortcut. But I need it from this direction, perpendicular to a C-plane facing me. So I need it from a front C-plane. Set C-plane world front. And now it doesn't matter if I'm really facing at it. I can drag from anywhere. I know that it'll work with this C-plane. Curve, from objects, section. Using the grid snap to keep it straight in the middle. Click outside, and you're finished. We now have the geometry that we wanted. So, we have this geometry that we need. We're going to do our variable fillet. Do one side at a time. Enter when done. And see it's saying select handle to fillet, to edit. So we could change any of these we want. But we don't have handles to grab onto to change it down here. So we're going to add a handle. Put on our end object snap. Intersect would work as well. We're going to click here. We're going to click here. When you're through putting new handles, hit enter. And now it's saying select handle to edit. Click inside here and type 0.85. Same thing on the other side. 0.5. What this is going to do is it's going to fillet this edge from here to here at 0.85, and then it's going to mathematically diminish it down to 0.4 as it reaches here. We may have to do some more handles to get better control of it, because we may have some things smacking into each other here. But always go for the low-hanging fruit first. See if it'll work. And that worked. Oh, we came close. But it worked. It's fine. Do the same thing on the other side. Add handle. Here. Here. Enter when done. Select handle to edit. This one, 0.85. This one, 0.85. Isn't that lovely? Okay. Now we have the challenge of doing something with this. Right? So, the only solution that we can do here is going to be a bi-rail sweep, something that is a fairly advanced technique. We've talked about it a little bit. This is a fairly advanced way to start with it, but it's the problem we're facing, so it is the solution we need. Getting a nice easy color to see, a nice dark blue would work. I'm going to do a blend curve, and a quick blend curve is fine because we're not going to adjust this thing at all. Click on the edge of the fillet and the edge of the fillet. You won't even see the curve really because we're in shaded. If we go into wireframe, You'll see this is the curve that we created. We want to pull this up onto the surface like elastic, wrap it around it, get it around the outside. There's a command for that. Curve from objects. We've done project, where it's like a light show, like a shadow puppet, and it projects it straight like a light behind it. Pull back is project's cousin. Pull back uses the surface like a magnet and pulls the curve up onto it. Select surfaces and meshes that pull. That one, that one, that one, that one. Press enter when done. And what we have is Rhino's best effort to do what we asked. Didn't work great, but it worked. I'm going to delete this, and these are really bad. Those are curves that loop around on themselves and are not going to be helpful. But this one is very helpful. I'm going to do a blend curve. Once again, a simple blend curve. Same thing here. See, the problem Rhino had was those curves. The first blend curve was too far from the surface for Rhino to have an intelligent idea about how to handle it. But we've solved that for it by doing a second generation of blend curves. We're going to pull those back. Select curves and points to pull. We're going to do one side at a time to keep the math easy for Rhino. Select surfaces and meshes that pull. This one, this one. See that? Done. Throw away the original. Having the original thrown away automatically is an option in the command line, which we will do for this one. Repeat the command, pull back. Delete input, yes. Okay. Select surfaces that pull. There's just that one. Lovely. Join these three together, or four. And we have our first rail. Remember when we did it before, we had to have two rails. We did this for the flow along surface command. You have to have two rails and a cross section like ties on a railroad. One rail sweep that we made for the prong has a single rail. You can control the flow of something, but you can't control its outer silhouette. With bi-rail sweep, you can control its outer silhouette. So it's a more sophisticated surfacing command. Now we need a rail inside here. We need a rail that connects these two. A blend curve is the obvious candidate. This one we will make adjustable. If we make it too pointy, well, grid snap is on. If we make it too pointy, it'll fail to work. I couldn't use a conic because actually these surfaces kind of diverge, the edges of these surfaces, so a conic would never come together, so it wouldn't let me. But I pulled these 2 points out approximately the same distance. If I want to make it, I've got end on. When you're adjusting any kind of handles within a command, guys, I'm actually going to escape out of that. This will put a little stronger pull at the base. Okay. It's interesting. I'm seeing something new here. I'm having an option for symmetry, which I want to explore. That curve will work just fine. You don't have to click along with me. You can just hold for a minute. I want to see if Rhino 5 has given us a way to do this. I'm going to hold down the Shift key and select this handle. Well, class, will you look at that? Haha. Blend curve just caught up with conic. You can now... Oh, that's a wonderful thing. That's the first really great innovation I've seen in Rhino 5. Kudos. Very nice. Okay. Enter. We're done. Very nice. This is not going to be right on this surface, and we need it to be right on that surface. So, I'm going to select our curve, pull back, select this surface to pull. We want delete input, yes, enter when done. And that's it. I'm going to put this on a different layer. One I can turn off. I'm going to do my bi-rail sweep. Sweep 2 rails. I am picking both of them near the beginning. You know, I either pick this one and this one toward the start, or this one and this one towards the start. If you pick this one at this end and this one at that end, it can actually flip your surface around. So try and be reasonably logical for Rhino to follow you. Cross-section curves, once again, I'll pick on this outer corner here and this outer corner here. And we'll hope that we get a civilized result. It isn't fabulous. There is some not great things happening with it. But I'll say okay. Because what I can do is I can use it to get me another cross-section. Curve from objects. The more cross-sections you have, class, the more control over the surface. Extract iso curve. I want one of these somewhere in here. I'll throw that away. I'll bring back my surface. Okay. This one right here. Okay. I'm going to use it to help me. It's not a curve I'm actually going to keep. From objects, extract iso curve. From this surface up to that end. Okay. And I'm going to do another line, single line, both sides. And I'm going to see what that's giving me. That's actually fine. And now this curve has served its purpose. This curve will need to be pulled back onto that surface because it's not going to be. Since this was an iso curve, I don't have to pull it back. It was actually pulled from the surface. I created this curve in midair by doing that single line command. I need to pull it back to the surface. You can see it's been pulled back because it loses its end there. Very nice. Very nice. That works fine. I'm going to trim the corner off. And I can do a conic, or I can do a blend. I think I'm going to try conic and see where it gets me. Curve, conic, tangent from the end of this curve, tangent from the end of this curve. Yeah, it's going to allow it. Just because it's likely to give me a more structured, controlled, smooth result than a blend curve. Very nice. I can throw away these bits. Now, where Rhino's going to have the hard time is around these tight corners. Rhino doesn't like tight corners. We know this. But we're going to get the best result we can. Sweep 2 rails. Rail 1, rail 2. Section curves. This curve, the one we just made. None of those. That curve. Okay. I don't know that the result is much more attractive than what we already had. Question is going to be how much of it's going to show. Model. Because it is going to bite in there. I'm not thrilled. I'm going to try it again and see if I can change some of the parameters. 2 rails, sections, I reduced the control point count. Refit within 0.1. See, I'm telling it not to take everything so seriously. Is what I'm telling it to do. To see if I can get a smoother kind of surface out of it. It's not going to work. Okay. I don't want to keep you focusing on this. This is a good place to end this tutorial. We will come back and resolve this problem with the next one. Thanks for watching.